Let's look at a quick example of truth table. This time, compared to previous example we did, there's a difference. That is, we have three simple statements in the compound statement. So this results in actually 8 rows in our truth table. The number of rows depends on how many truth value combinations we have for the simple statements. In this case, since we have 3, there are going to be 8 truth value combinations. So let's create a truth table. The simple statements P, Q, and R take up 3 columns. Next, a quick glance tells me all 3 simple statements have to be negated. Not R, not Q, and not P, all are needed at one point. So let's make those first. Again, I'm going to use red for the operation I'm doing under each of these statements. So now we can work on Q and not R, and also I can create the first truth table. Again, if you carefully look at each of those operations in red, whenever I start on those operations, I have all the truth statements I need for those operations. So now we also need Q or not Q or R, so we can make that one. And finally, the last statement. We have created the truth values for the 2 statements in the same truth table, because now we can compare those two. Two truth tables, truth statements are equivalent, means they have the same truth value. So if you make them in one table, it's easier to compare. So for R, one easy way of getting all the combinations is just alternating T and F down the column of R. T, F, T, F, T, F, T, F. Q, I alternate it every other entry. T, T, F, F, T, T, F, F. The last one I alternate once in 4 entries. T, 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 F, 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 F. If you carefully look at the table now, all of them are different. You don't have any truth value combination repeated. T, 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 T is not repeated anywhere. Similarly, T, T, F, T, F, T, I can go down the columns like that. None of them are repeated. And if you try to write a 9th combination, you're going to repeat one of the combinations we already have. So we have all the possible truth value combinations for P, Q, and R. There are going to be 8 such combinations, and we have all of them. So now the second part of the truth value the table. We have to fill in the first 6 columns, actually first 3 columns, so we can create the first truth table, and also the next column and the last statement. So let's negate P. Negation of P is simply you invert the truth value. Same for Q, same for R. Q and not R, you look at the Q column and not R column, nothing else. You keep your fingers on Q and not R column and go down the rows. So the first one is T, F, and is false if one of them is false. So we have F for the first one. Second one, T, T gives you T, and similarly for the rest of the entries. Now for the conditional statement or the implication. Make sure you start from the right column and go to the right column. In this case, P implies Q and not R. So start with the P column, find out the Q and not R column, and compare the truth values in those columns. P is true, Q and not R is false. So something true implying false. That's the only time conditional statement is false. So the result is false. Second one, P is true, Q and not R is true. So it's not, T implies F, therefore it's true. Similarly, third one, we have P is true, Q and not R false, so the result is false. Fourth one, the same thing, something true implying something false, so the result is false. 5th, 6th, 7th and 8th, let's take a shortcut. P is always false for the remaining rows. So I know that it will never be something true implying something false because you're starting with something false. So I know all of them are true. So now I need to go and do not Q or R. So not Q or R, look at the not Q column and R column. This is false only in one case, when both of them are false. So here are the truth values for that statement. Now we're ready for the last one. Implication again. For the conditional statement, make sure you do not mix up with antecedent and precedent. If you mix them up, you will run into trouble because the truth values are going to be different. So not Q or R implies not P. So here are the truth values. So now I can compare the two statements. P implies Q or not R, and not Q or R implies not P. For each row, they have the same outcome. They are together taking the same truth values for the same truth value combinations of P, Q and R. Therefore, the conclusion, they are equivalent. Remember, if at least one of these truth values are different, the statements are not equivalent. Equivalent means all of them are the same.